Shamir Charania. I am a managing director at a consulting company here in Calgary called KeepSecure. And you can reach me via email there, shamir@keepsecure.ca, or you can @ me on Twitter. I don't tweet too much, but I definitely enjoy following some of the cybersecurity conversation that's going on there. So today we're going to talk about Azure Databricks, and we're going to talk about some of the key kind of automation areas when it comes to Azure Databricks. Typically, when companies go or projects or whatever, and they start spinning up these kind of PaaS services, they don't realize all the different intricacies of those PaaS services and all the things and all the configuration that you still kind of have to provide to that service in kind of a declarative or imperative fashion. And so it can catch people by surprise as to how much actually goes into building and maintaining some of these environments, given the fact that Azure Databricks sells itself as an automation tool itself in terms of distributing the clusters and jobs and kind of doing all of those things for you. So hopefully going to go through Azure Databricks, what it is. I'm going to touch on some of the key automation areas. I'm going to probably give some thoughts around security as we go through the presentation. And then, hopefully any questions, drop them in chat, or we can address them at the end. Some of this is a little heavy. I've updated the presentation a little bit from the first time I gave it about a year ago. So hopefully it goes a little bit smoother this time. And yeah, there's a lot to cover, and so hopefully I'll be able to get through it. So before we get too deep into it, kind of want, I guess, people in the audience to take off the data engineering hat or the data science hat and kind of put on your Devops engineer hat. So you typically have a very particular set of skills. You're at home with kind of doing things, scripting languages like PowerShell, Bash, Python. You're very familiar with YAML and JSON in terms of creating configuration files that are then passed to downstream services. You're always worried about all the things that could go wrong in your environment because you're typically the first person to get blamed. Most DevOps people juggle professionally, and they typically distrust anybody outside of the family. So that's kind of who we are today. And the problem that we're trying to solve is when your manager walks in and they just read about Azure Databricks and they think it's amazing, and now they want you to automate it. But of course, the problem is, what is it? What are they referring to when they say, I want you to automate Azure Databricks? So the first thing is what is Azure Databricks as a service? Well, it purports to be a fully managed Spark cluster environment. So it's effectively taking the Apache Spark product. Now they've got some customized builds, and then they do a bunch of proprietary things to the open source product. And the idea is that when you spin up an Azure Databricks environment, it's fully managed Spark for you. So you don't have to go and install all the Spark driver nodes and cluster node software and wire everything up so that everything can communicate. All of those pieces are done for you. It provides an interactive workspace for data exploration. They have built specific optimizations for the Azure environment. So they're trying to leverage the different compute instances and options that make sense when you're doing data, big data processing. They've provided a programmatic API that allows you to configure different parts of the platform. So different parts of kind of the data plane of the platform, if you can think about it like that. And it has built-in ways to integrate with existing Azure services. So for those of you who have not seen Azure Databricks, that on the left here is kind of what a workspace looks like. So pretty simple. You log in, you get a set of options, and you can navigate to typically what data scientists or data engineers will be using is kind of the notebooks tab, and that's where you can write your Python in a Jupyter-like experience, and then you can execute commands on there. The workspace also represents configuration for how the rest of the environment within that Databricks workspace, I guess, a logical container, will operate. So you'll be able to configure clusters in there, things like instance pools. You'll be able to do users and stuff like that. You'll actually also be able to create tables and do table ACLs and so on and so forth. So it's your main kind of viewport into that PaaS service offering, and it allows you to configure all the different areas of that. So Spark itself, if you're unfamiliar, is a distributed computing paradigm or set of software where effectively you have a driver node that is executing jobs, and the driver communicates with a set of what's called executors, and those executors can live, anywhere else. They can live on, say, the physical computing host that the driver lives on, or they can live on any other set of virtual machines or whatever, and they communicate to each other via private communication. And so typically with a Spark cluster, you're going to have one driver node that is managing job state, their execution, and it's also going to be managing load across all of the executors. And then you're going to have one or more executors depending on how fast you want to get your job done. So this is kind of the core part of the Databricks product itself. So another thing that you kind of have to understand as we're going through this is what a big data pipeline architecture looks like. So typically, this is a little bit of an older diagram, as I'm sure Steve and the next presenter will point out. But it's still got Azure SQL Data Warehouse on there. But typically, when you're creating a big data pipeline architecture in Azure, this is what it's going to kind of look like. You're going to have various data sources that you're going to want to be ingesting data from. You will typically use something like Azure Data Factory to actually pull in that data, which will store into your Azure Data Lake storage. You may or may not use Azure Data Explorer to kind of perform some data exploration type activities. You're typically going to use Azure Databricks when you want to start pulling in or start operationalizing some of your analytics and in producing jobs that have meaningful output. Then you're typically going to either put that into traditional tools like Azure SQL Data Warehouse, or directly into something like Power BI, or even have Power BI that's reading directly off of the Azure Data Lake storage. So Databricks kind of fits in the middle of all of these different operations, and it's a core part when you want to start transforming your data in different ways, towards transforming and combining your data in different ways to yield those insights. Fun fact is that the Azure Databricks as a platform is really trying to do actually all 5 of the different components all at once. So with Azure Databricks streaming, for example, you could skip the Azure Data Factory type steps and actually stream directly into Databricks and then persist that into your data lake storage. You can use the notebook interfaces to replicate what they're doing in Azure Data Explorer, particularly with the table views and being able to create tables that end users can interact with directly. And then they also do have Azure SQL Data Analytics, or I can't remember exactly what the product name is called, that would compete, say, with a Power BI visualization, for example, where users can use that to write SQL directly against the data that's in the data lake, and then produce cool visualizations through that tool set. So they're kind of expanding their offering to kind of be able to do the pipeline end to end. But typically, this is what we see when we're looking in client environments. And so let's talk about the overall Databricks architecture. So you have a separation between the control plane and the data plane from a Databricks perspective. The control plane itself lives somewhere else within the Azure data center, and it's controlled by Databricks. And so this is where, when you're logging into a workspace, that's what you're going to be logging into, that control plane itself. It lives outside of your environment. You don't have any control over it, other than the options that they make available through API or through the portal. That's where you're going to do your configure your notebooks or write your code. If you're going to create your jobs, you're going to configure your clusters. You're going to do all of those types of things in that kind of control plane. When the control plane actually wants to kick off a job to actually go and process some data, it's going to then basically relay a request to the data plane. And there's a few different modes that Databricks can be deployed in. This one that I'm showing here is just the standard mode that comes out of the box. Effectively, what will happen is, in your subscription now, Databricks will create a virtual network where it can then attach all of its compute nodes so that it can process all of that data. And then from that virtual network, it'll make connections out to your various systems that it might need to. For example, your data lake storage, or it could talk directly to SQL, or you could be using some Kafka. all of those types of things that they're showing on the diagram here. So it's important to understand that there's this separation between what's in your control from a scripting automation perspective, or even from a subscription perspective, and what is in the control of Databricks, and those areas that you can't necessarily see or touch. Another thing to kind of talk about here, and again, we're still talking about what is Databricks, is the Databricks REST API 2.0. So this is their latest version of their REST API, and effectively what they're trying to do is provide or surface a whole bunch of the configuration options that were kind of hidden in the portal for the longest time, so that you can interact with them programmatically. So clusters and libraries and workspaces, these are all kind of first level or first party components of the Databricks REST API. Most of the things that you'd want to do within Databricks can all be configured via REST. There's still some type of admin type options that you would have to actually go and work in through the portal, but most of the other ones can actually be configured via the REST API. Authentication is typically done via personal access token. But they do have a preview for OAuth, and I think the slide's a little dated now because I think OAuth is generally available, which effectively means that you can log in directly using your Azure Active Directory username and password, and that whole related system, or you can actually log in now using service principals. So when you're configuring your Databricks environment, you don't have to necessarily do it as your user. You can actually build that automation to run off of service principals, and it's kind of a cleaner way of doing things. Databricks also provides a CLI wrapper that sits over top of the REST API. It's effectively a very thin wrapper. All it does is pass JSON objects back and forth. And so if you're using if you're using it in Linux, for example, you'll have to parse things through JQ, for example, to start being able to interact with those JSON objects at first party, and in PowerShell, you'd be able to just convert a response to an actual object. And so just think about it. It's a very, very thin wrapper, but some of the options that the CLI provides, because it's its own little product, aren't necessarily in line with all the REST APIs. So both of them are kind of developed not necessarily in sync with each other. And then the last point that I have there is just consider creating a service account to kind of handle that automation. So we've covered a bunch of different things about what Databricks is. The fact that it's this PaaS service. It's really its core reason is automating Spark and Spark job distribution. And so when you're thinking about Databricks and you're thinking about all the areas as it relates to a particular Databricks environment, you can kind of break them into these four major components. If we start in the bottom left, one of them is networking. So your compute nodes that you're spinning up in whether it's in the Microsoft managed virtual network or in a customer managed one, for example, needs to be able to talk back to the management plane. That's where it's getting all of its instructions from. That's where the notebooks and the notebook results get stored. And so it needs to be able to have kind of two-way communication between your nodes and the management plane. And then, of course, your nodes need to be able to, or your cluster nodes need to be able to talk to, sources and destinations, right? So data lake and SQL and stuff like that. So you've got your kind of your data plane, whether it's in the cloud, if that kind of makes sense, and then you've also got your data plane, whether it's on-prem. In a lot of cases, you might connect your Databricks environment directly to an on-prem SQL server, for example, and so your connecting or your networking there is going to look a little bit different in that use case. Going to the top left, we have the compute there, and so compute can kind of be broken down into three areas. One of them is the compute setup itself. So think about the spinning up of a virtual machine, and then the adding the particular pieces of software that need to be on there, whether they are the Apache Spark runtime itself, or it could be Python libraries, it could be other things that you might need on that compute to actually allow it to work. You've got the concept of job distribution. So this is where, from a distributed computing architecture, when you're submitting a job, Databricks is going to basically carve that up, either based off of the data that it's using, or based off of the actual operations that it's running. And based off of that job carving, it's going to distribute that to all the different executor nodes. And so that's going to be a piece that has to be automated and dealt with. And then you've got the compute config itself. And so would be parameters on the compute, whether it can auto scale, how many nodes you're going to assign, how much money you might want to spend on a particular job, that kind of thing. Top right, you get into identity. So you typically have identity in kind of two locations. One is identity into the management plane. So who in your organization can log into the Databricks workspace and actually execute jobs and execute, or write notebooks, for example. And then the identity to the data plane itself. And so this is where you're going to have potentially service accounts that are reaching out to these different locations to actually access the data. And so you've got identity across those two planes. And then you've got the Databricks just general configuration, uploading code, writing code, creating secrets, configuring jobs, setting permissions, and then there's some workspace type configuration that you have to kind of deal with. So when we're thinking about what it is that we are automating, this is what that complete ecosphere kind of looks like, right? And so then the question becomes, well, what does Azure Databricks make easier for us? And so you'll see yellow is kind of the area where Azure Databricks is providing services that help make some of these things a little bit easier. From a networking standpoint, depending on your networking topology, Azure Databricks will pre-configure itself to work with that topology, but it's not complete. There are some areas where, especially when you're integrating with large enterprise customers that have a bunch of existing systems or a bunch of existing networking in place, it's not complete. It's got the options there, but you still need to do a little bit of work to make that work. When it comes to connecting to the data plane, whether it's either cloud or on-prem, Azure Databricks doesn't do anything there, right? They're just configuring their cluster, or they're allowing you to place your clusters in kind of a virtual network that either you control or you don't, and whether you allow that networking area to reach your data sinks and sources is up to you. So you still need to go out and kind of configure all of those pieces. From a compute perspective, obviously job distribution and compute setup is where Azure Databricks does a whole bunch of work there. But again, it's not quite complete. It leaves a little bit of those things to be desired, and we're going to talk about some of these different pieces. So to give you an example, in the compute setup, compute config area, when you spin up an Azure Databricks compute node, you get the Azure Databricks runtime, right? And the Spark runtime, but nothing, and Python and Java and some of those other things, but you don't get any kind of third-party libraries or packages automatically set up there. If you want that to happen, or if you need that to happen, for example, maybe you need pandas in addition to whatever else you're doing there, you're going to have to configure that yourself. You're going to have to create that configuration, distribute it into Databricks, and then make sure that it's being set up and installed properly at the time that you need it. So there's a lot to kind of even go in there, even though that's what Azure Databricks is trying to make easier for us. From an identity perspective, they've provided some API type stuff that we'll talk about in terms of syncing users for the management plane perspective. But on the data plane, they don't really do a ton, right? They give you an option, which is called secret scopes, to be able to store secret information so that you can make connections as service principals, for example. But there's not a ton around the actual provisioning, setup, and distribution of all of those secrets. You still have to kind of handle all of that from an automation perspective. And then lastly, from a Databricks just core perspective, they've established an API that allows you to programmatically interface with the workspace to create and upload code, create and edit secrets, create and edit jobs and permissions. But you still have to tell it what to do. You still have to be opinionated in that particular environment and what it should and shouldn't be doing. And so all of that automation is kind of left up to you. So parts of it are done in the sense that it's surfaced as a capability, but still something that you have to consider for yourself. And so then, how far you go down the automation path is always going to be project and solution dependent, right? So if I just go back a slide, I'm not suggesting that all of these things always have to be completely automated, but when you get down to these types of processes where you've got these big data pipelines and you've got some established code procedure or software development lifecycle where you're testing and promoting code, you're going to want, by the time some of these jobs get into production, for it to be fairly automated, so that there's a high degree of assurance that your job and your code are going to run as expected, because all of its dependencies and all of the identity and all of the configuration has been baked in and automated in prior steps, right? You get into a lot of problems when you start trying to manually replicate different types of configuration across these different environments. And so that's where depending on how you're using Databricks and depending on what your specific use cases or say compliance requirements are, you're going to automate kind of different areas of it. So I'll just take a stop here. We've covered a ton. Are there any questions so far, or?
I don't see any questions in the chat.
Okay. Oh, I think somebody raised their hand. Amkar?
Hey, hi. So I have a quick question here. I mean, you're talking about the jobs, right? So in creation of jobs in Azure Databricks. So I have a quick question there. I know that, for example, if you create a notebook with a bunch of code there, and then you can call that notebook in the Azure Data Factory to do your processing. Maybe that can be in the batches or maybe real time. So my question is, I mean, do we have any other components from where you see that these notebooks are being called, other than calling them from ADF?
Like in terms of being triggered?
Mm-hmm. Yeah.
Yeah, so typically people will trigger them from ADF, as you're suggesting, and then Jobs has its own kind of scheduling engine. And so what I'm seeing is that people taking a Databricks centric approach will actually not run things through ADF and actually have, say, streaming jobs run directly from the Jobs engine within Databricks.
Okay, got it. Yeah. Thank you.
No problem. All right. Don't see any other hands, so we'll keep going here. So the goal of this section here, so we've kind of covered what Databricks is at a very high and very quick level, and we've talked about a little bit of the different automation engines um, the automation areas that we can use. I just saw something in the chat here. Jobs are cheaper too. Yeah, they definitely are if you're running them on the job clusters. If you run them on the interactive clusters, then it's effectively the same. But so we've talked about the different areas as well that we can automate, and obviously kind of get an understanding of the scope of the problem. Like we can go very little, and we can go into quite a depth. So the goal of this section is to just talk about a couple of these different areas, because it'd be hard to kind of cover every single one, and just dive a little bit into what some of the automation techniques can be and what some of the considerations might be when you are automating these areas, right? The first one is around configuration layers and options. So taking a little bit of a different view on what you're automating. Whenever you automate anything into Azure, you've got this kind of separation between what we would call the Azure resource plane, which is interacting with the Azure management APIs to actually create a resource. And then you've got this kind of post configuration plane, which is where you're configuring with configuring um, the the resource that you've now created, and you're providing some kind of post configuration to further configure that particular resource. And so when we're dealing with Azure resources or Azure RBAC, which stands for role-based access control, you're typically using the Azure Resource Manager, which is its own API, and you'll typically interface with that using ARM or Bicep templates, which is ARM 2.0, I guess, if you haven't heard about it. or you'll do something directly through the portal, or you'll use something like PowerShell or the AZ CLI to be able to interface directly with those Azure resources and create them. When we're dealing with the post configuration, which is doing configuration on Azure Databricks itself, or we're setting up access or trying to call jobs or do something else like that, we will be interfacing directly with the Databricks REST API. And your typical tool sets there are to either use the Databricks CLI, which is a tool released by Databricks. You can obviously use the Workspace UI and kind of click around in there, or you can just basically build your own wrapper around the REST API to make the calls that you want it to make. So the first automation area we'll talk about is workspace automation. There's a couple of key things that you want to think about here. The first is what's called no public IP. So this is a kind of a security option configuration that exists in Azure Databricks. So typically what happens in the default mode is that two-way communication is required between the workspace or the control plane and the cluster nodes. So the workspace will issue a command to the cluster nodes, and the cluster nodes will actually talk back out through the internet and submit their results. When you enable no public IP, there is no more inbound communication between the management plane and the control plane. So it basically switches the cluster plane. It basically switches the cluster plane to a polling type of situation where it's doing a long-term poll and kind of waiting for instructions from the management plane. The reason why you're going to want to do this is because trying to get security teams, particularly at large organizations, to allow inbound connections from the internet, particularly when their management connections can be quite difficult. And so the no public IP helps to reduce that threat attack surface a little bit by preventing or no longer requiring those inbound connections. The next thing is going to be a managed RG or managed resource group. So what you can actually do is you can instruct Databricks and you can tell it what resource group name you want it to use when it's creating clusters and virtual networks and storage accounts and so on and so on and so forth. And where this can come in really handy is because you can provide that name up front, you can feed that name into your downstream reporting systems, around cost controls and other things like that. So you can really get a good understanding of how much your Databricks environment is costing you because you can provide all these names up front that will then kind of fit into all of those different paradigms. You can configure the default file system. So every Databricks workspace comes with a default file system, and you can provide some configuration around that. This the tooling in this one has gotten a lot better, but typically people don't realize that Azure Databricks actually spins up its own root file system, and if people were to write out results there, for example, they would be taking data from a high secure environment, let's say, and then writing it out to a low secure environment, not even realizing that they're doing that, or not even realizing that process is happening while, say, temp files and things like that are being written. So you're going to want to configure that default file system and make sure that it's either got the security that you want it to have, and that it matches the rest of your environment. You can obviously pick the SKU, premium or standard, or I think there's a few other different options now. You can do what's called VNet injection, which we'll talk about in a little bit, and then you can also configure mount points, which basically make storage accounts globally accessible across that workspace. So when we're dealing with workspace automation, we're going to be doing most of this through ARM templates because all of these things are configurable at the Azure Resource Manager management plane. And so you can configure all of these things in the ARM template. I just got a link here to the ARM template reference for Microsoft Databricks, and you can go in there and you can see that all these different options are available as long as you're configuring them the way that you want to. So we're just touching a little bit on Databricks VNet injection. If you remember from the earlier architecture slide, the control plane obviously still lives out in somebody else's subscription, but the cluster plane or the data plane in this case was living in a Microsoft managed Databricks workspace VNet. What you can do is configure what's called VNet injection, where instead of Databricks building and controlling your its own virtual network to deploy your cluster nodes, you can actually give it one of yours that you have pre-configured. And this becomes really important when you want to create private access to more than just Azure resources. You want to be able to VNet peer, and in this case, like the diagram is showing, to a network virtual appliance, which could then provide privileged access into an on-prem customer environment, for example. You can also then use it to use things like service endpoints, which provide for more private communication between your cluster nodes and anything deployed in Azure, like a storage account, data lake store, event hub, SQL Server, and other things like that. Lastly, you can configure the network security groups and even configure traffic routing so that when you do start doing outbound communication from these cluster nodes, they can go through and meet your security policies that you might want to meet. There's a data exfiltration blog post that Databricks had written up maybe a year or two ago now, and VNet injection is a core part of that, because you can start controlling where that traffic, the outbound traffic, goes, and you can start inspecting that to make sure that there's no data exfiltration out of your environment. So now we've talked a little bit about workspaces, and we've talked a little bit about some of the things that you have to think about when you're configuring workspaces. Let's talk a little bit about clusters. So clusters are, again, your core compute engine. Typically, a cluster can use what's called instance pools. And instance pools are effectively just a reserved set of compute that you can put parameters on to keep things constantly warm, if that makes sense. Keeping them warm and keeping them with the runtime already installed on them reduces your startup time, and thereby reducing some of your costs. Because I think, if I remember correctly, you pay for every second that the cluster is not in terminated mode. And so even while it's starting up, if it takes, let's say, 1 to 3 minutes for an Azure VM to spin up and get the runtime installed, you're actually paying for that compute, even though you're not actually processing any of your jobs. So pools can help you manage that element. And then a cluster has various different configuration pieces that you have to worry about. The first one is obviously the runtime. So most people, I think, are using 8 these days, but depending on what version of code you have, you're going to want to make sure that you're running it on the right runtime version. This becomes also really important in cases where you're using Databricks Connect, for example, in dev environments where the version of the Databricks Connect that you're using has to match exactly the version that's running on your clusters. Otherwise, that process will fail. You're also going to want to be setting up things like permissions, who can kind of fire up some of these clusters. You're going to want to set the mode on the cluster, whether Azure Active Directory pass-through is enabled, whether it's a high-performance cluster versus a single cluster. You're going to want to be able to configure things like environment variables in your Spark config. You're going to want to be able to set things like nodes and either min or max, or putting your clusters in what's called auto scale mode, where they try and understand what your usage is going to be over time of a particular job, and then scale the clusters appropriately to that. And then last but not least, you're going to want to deal with libraries and init scripts, which we'll talk about here a little bit more in the next slide. So init scripts and libraries are kind of a little bit of a unique thing across workspaces from a Databricks perspective. So you typically use init scripts and libraries when you want to further customize your compute environment by installing, again, third-party libraries. In some cases, init scripts are actually required to install those libraries, because you might need to do some builds locally on those servers to build some of those components, whatever that might be. You might also want to set up different networking. You might want to pre-configure mounts. You might want to do a whole bunch of different things. With that, you might want to harden some of your clusters, et cetera, et cetera, et cetera. Forward logs, lots of different use cases. When you're creating init scripts and libraries, you can create them at 3 different scopes. Although init scripts don't make a lot of sense at the notebook level, but you can create them at 3 different scopes. And they typically require the use of the local root file system that we were talking about earlier when we were configuring the workspace automation. So you're going to consider using CI/CD processes to basically handle these complexities. But when you set up init scripts and libraries at the workspace scope, every cluster that gets spun up will automatically inherit that init script and library configuration and automatically apply it. And then same thing from a cluster perspective to notebooks, especially with libraries. Those libraries are going to be installed at cluster startup time, so they're going to be available to every single notebook. And then from a notebook perspective, you can actually have notebook scoped libraries. And this becomes particularly important when you have multiple notebooks that require different versions of dependent libraries. And so you might want to be installing those libraries at the notebook level and not at the cluster level, for example. So again, different automation things that you're going to have to worry about. So from your cluster automation strategy perspective, there's typically two ways that you can do this. One is user-led, and one is DevOps-led. So if you have, let's say, data science workspaces where you have users that are kind of in and out of those environments, what you might want to do is allow them to create clusters when they need them, and then to destroy those clusters or terminate those clusters, when they're done, right? And so you can use what's called cluster policies to configure the environment so that clusters are created with predefined sets of configuration. And so you can automate things like auto terminate times, for example. Like you don't want your clusters to run if they're idle, and so you'll want to set your auto termination time to 10 minutes or 20 minutes or 30 minutes or whatever that is, depending on that. And then you're going to want to also set up other things around permissions. You might want to set up the number of nodes, for example. You might want to set up node types. So your user who just wants to browse the data lake, for example, doesn't spin up a GPU backed cluster with 20 nodes in it, just for that one particular operation. So if your use case from a workspace perspective is to have users be creating clusters, then you can rely on cluster policies to kind of do that for you. If it's more of a data engineering type workspace or more of a job runner type workspace, then you're going to want to probably just hit the REST API directly and be able to configure those clusters at kind of workspace deployment time, right? So those are kind of your two strategies here. All right, so we've talked about workspaces, we've talked about clusters. Let's talk a little bit about Databricks users. So Databricks users they're effectively a local resource within Databricks. The authentication is tied to Azure Active Directory, so it's tied to the tenant that the Databricks workspace is deployed to. But the authorization for what that user can do is all controlled within Databricks. And the other kind of key piece here is that contributors on a particular Databricks workspace are automatically added as administrators when they try and log in. So this could be one of those areas where, if you've got those workspaces that are configured and there's secret scopes and all these other things that are set up, you have to remember that your Azure management plane, role-based access control, bleeds into your data plane here, and this is how it does that. So you'd want to make sure that whoever has contributor access to the Azure resources, should have that, because they'll automatically get added as an admin when they try and log in. Setting up users. So for those of you who don't know, there's a open standard called the System for Cross-Identity Management, and so the whole idea behind this system is to make easier the process of onboarding and offboarding users between these disparate systems. And so Azure Active Directory can act as, or can talk SIM or SCIM, or however it's pronounced. SCIM is the acronym for that. And so what it can do in this case is when users are added, let's say, to a particular group or to a particular enterprise application inside of Azure Active Directory, that user can then automatically be populated in that target system. And there's a whole bunch of applications that this works for, Azure Databricks being one of them. So Azure Databricks has a SCIM plugin So it's an append-only type functionality. So this kind of gives you a little bit of leeway in which you can create groups and users within the Databricks management plane and then start syncing. So it's not like an all or nothing type approach there. You can configure the users and groups to provision, so you can limit who has access to that using the controls within Azure Active Directory. The sync happens every 20 to 40 minutes, so it's not immediate, if that kind of makes sense. But if it's part of, if you automate it as part of your provisioning process, know that at some point in the future it'll happen. And at time of writing, it still required personal access tokens to set up this particular connection between Azure Active Directory and your target workspace. So the idea here is that you would have one of these enterprise applications installed for each workspace you wanted to manage in this way. And then you would likely just create a group, let's say, Databricks developers, for example, that you would add users to whenever they get onboarded, and then this SCIM would automatically add their user to the target workspace with that group name. And then entitlements and all of those other things can happen through what's called the Permissions API, which I think I talked to in a little bit. So when you're thinking about these pieces, you've got to think about who has access to what parts of the workspace, and the users via SCIM can kind of help simplify that whole piece there. So the next piece then is to talk about permissions automation. So we've got our workspace set up. We've got some clusters now that are available for use, and we've tied the creation of users and onboarding of users to Azure Active Directory. So both from an Azure Active Directory perspective, they are authenticated, and we also get the group information so that we can then start putting that through the permissions. Give it the right set of grants within Databricks. So it's generally configured via the UI, but there is an API, and I think it's almost out of preview. It's only available on the premium plan, and it's usually applied after the targets have been created. So you typically do it as kind of a second step. So for example, you would create a cluster, you would give it its cluster configuration, and then you would call the permissions API and say, hey, give this group run permission to this cluster, for example. And you can set permissions on jobs, on clusters, on pools, on directories, and on notebooks. And so what you can use the permissions API for is to get pretty granular in the different user personas that are accessing your environment and what they can kind of do inside of that environment. So just to give you an example, say your support team needs access to your prod environment, you likely don't want them changing notebooks, right? They need to be able to see the notebook so they can see the notebook results, so they can see the results of job runs, but you don't want them editing notebooks, and you don't want them editing secret scopes and doing other things like that. So you can accomplish that type of use case persona via the permissions API. Versus a data analytics user who should be able to edit notebooks because they're doing exploratory work, but they should be able to maybe not create new clusters, but restart clusters that already exist that may have been terminated so that they can run their notebooks. And this is one of those ways where you can control what the data analytics user is using and hopefully control some of those costs so that they're not spinning up a massive amount of resources for a very small job. So I think this is the last core concept area that I kind of talk about, and then I get into just some steps overviews. So just bear with me for a few more minutes. So the last piece here is configuring your integrations, and so your Databricks cluster itself. So we've got a cluster. The person has the right permission to create a notebook and to assign it to that cluster or attach it to that cluster so it can run. Now that cluster has to actually reach out to things like event hubs and SQL and data lakes, and it uses all these different protocols. And typically this is all done within Python or within Java. You're going to create a connection object. But the question becomes, where do you get the secret material that you're going to be using to connect to those protected resources? And the answer to that is Databricks secret scopes. Now, secret scopes can be backed by Azure Key Vault, which is the recommended pattern here. And it provides a very nice segregation between your operational teams who might configure the keys inside the Key Vault and your data teams who just simply need to use those secret scopes but never actually see what's in there. And so it's a good separation there. And so typically you would create an Azure Key Vault, you would populate it with, let's say, your SQL Server password, and then you would surface that through secret scopes with the appropriate permissions, which we talked about just earlier. And then when a user goes to actually run some of their code, provided they have the right permission to that secret scope, they'll be able to read the SQL password and then establish a connection to the downstream resource. So that's how this all kind of starts to fit together in terms of actually executing a notebook to actually do something real with it, if that makes sense. And so the last piece here that we kind of talk about is, how are we making sure we know who's done what within our Databricks environment, right? And so typically what you'll see is, organizations who are just adopting this will stick with using service principals to do all their backend connections, right? Connecting to SQL Server as a service principal, connecting to the data lake as a service principal, and so on and so on and so forth. Well, what we can do is start to use the user's identity to be able to segregate some of these operations, and then to be able to audit on it as well. One of the big ones is the data lake. So if you use clusters that are configured with Azure Active Directory pass-through, you will actually be able to see that user accessing, deleting, updating data in the logs on the data lake, and it'll help you build that kind of audit trail for how those services and how that data is being used. Further, the Azure Active Directory pass-through can be combined with ACLs on the data lake itself to make sure that users only have access to the data that they actually require. And so it's kind of a little bit higher on that maturity level, but where you want to get to, it requires the automation that we've talked about so far to be able to get to this point where you can actually enforce that force user identity across your entire Databricks spectrum. So just quickly recapping, let's talk about the kind of Databricks setup steps. So step one, you're going to create a bunch of resource groups that you're going to want to deploy your Databricks resources to. You're probably going to want to create some key vaults and other things like that, and you're going to use ARM templates to do those activities. Next, you're going to want to probably create a virtual network, and this is so that we can support the VNet injection features of Azure Databricks. Again, there's going to be an ARM template for that. You just have to simply remember that subnets are assigned to a given workspace, and you can never have more than one workspace use a set of subnets. So there's a little bit of network planning that kind of has to go in there, but ARM templates can be used. Next, you're going to create your key vaults. You're going to want to consider your secret scopes and the fact that once you create a key vault, anybody who has access to that key vault has access to all the keys within the key vault. There's no kind of more granular permissioning there. So you're going to want to consider your secret scopes architecture, and you're going to only want to provide the necessary users, groups, and admins access to those key vaults. Again, you're going to be able to use ARM templates to accomplish that. You're then going to want to create your workspace. You're going to consider your tiers and your VNet support and so on and so forth. That's an Azure resource. So an ARM template is going to be what you're going to want to do there. When you get into users, you're going to want to set up the SCIM, which we talk about, which will sync all those users for you and help with those user onboarding, offboarding scenarios. And then lastly, you're going to create your Databricks objects, which are all going to be done through API. And you can, again, use the Databricks CLI or build your own wrapper. And the last part of that is obviously assigning the appropriate permissions. And then step 7, if you're lucky, I think you get to make some money. And so at the end of these 6 steps, you effectively now have a Databricks environment that can actually be used in a secure manner that is audited, controlled, and understood, well understood, because it's all being done through automation. Last 2 slides, I promise. So the first one is kind of a security concern, which is around the control plane. This slide's a little bit out of date because there's some newer features here, but the important thing to understand is that when you're executing notebooks in the Azure Databricks environment, the result of that notebook is stored by default in a MySQL database that you don't control. And so it's one of those areas where potentially data could be exfiltrated out of your working environment, or where you might want to keep those results safe. Databricks now has options to eliminate the fact that results are being stored in MySQL and stored directly on the root DBFS file system that is created as part of your workspace provisioning, and so you get a little bit more control over where that's going to sit. And the second one is cluster communication. This is one that often gets missed. The communication between all the different clusters when they're combining their data together is done insecure by default. So there's TLS is not enabled between those clusters, and you would have to create basically an init script to set that up. So that brings us, I believe, to the end. Thank you very much. Yeah, awesome. That's all I had. If there wasn't any questions, hopefully the material wasn't too dense, but there's definitely a lot to consider when you're automating Databricks. So hopefully you guys enjoyed.